Have you ever wondered why modern high jumpers jump backwards instead of forwards? Well, it's thanks to a guy named Dick Fosbury. In the 1960s, Fosbury tried his hands on many sports, but he could never accelerate on any one of them until he tried high jumping at the age of 16. Fosbury had many competitors, most of which were a lot stronger and taller than he was. While failing to complete jumps of only 1.5 meters, Fosbury knew that his dominant technique, the strata method, a complex motion where an athlete went over the high jump bar facing down and lifted his legs individually over the bar, was to be changed. As Fosbury began to experiment with different and much simpler methods of reaching greater heights, he finally found one that no one else had thought of before. He jumped backwards towards the bar, increasing his record by over half a foot, leaving his coaches in astonishment. As the years passed, Fosbury practiced his method each day until he finally perfected his technique, winning the U.S. national trials, and made his way to the 1968 U.S. Olympics in Mexico. During the 1968 U.S. Olympics in Mexico, Fosbury amazed the world with his new technique, winning a gold medal with an Olympic record of 2.24 meters. The following U.S. Olympic Games, competitors from across the nation began to adopt Fosbury's technique. This revolutionary technique became known to be called the Fosbury flop. So why did the Fosbury flop triumph over the traditional technique? The answer is known to be a physics concept called the center of mass. The center of mass is a point where the main weight of an object is concentrated, taking into account external forces or weights. Take for example a piece of paper. The center of mass of that piece of paper can be found by drawing diagonal lines from each corner. The diagonal lines will form an intersection called the center of mass. This same method can be used to find the center of mass of other objects, such as a circle or a weird blob-looking thing. If you find the balancing point of an object, you could also find the center of mass, which lies above the balancing point. Take for instance a crane. If you place your hand on both ends of the stick and slowly bring your hands together, where your two hands connect lies your balancing point, and above that is your center of mass. Everything has a center of mass, including humans. When we stand with our bodies shaped like a T, our center of mass is right near our stomach. But if we bring our hands straight up, forming an I, our center of mass has now shifted upwards near our chest. As we move throughout the day, our body position is constantly changing, thus changing the position of the center of mass. The center of mass can be found outside our body. When you reach over to pick up a piece of pencil, the center of mass is positioned right underneath the arch you form with your body. Even though there's no mass at that position, that's where the average mass of your body lies. Many objects have center of masses outside their bodies, such as boomerangs or donuts. Now, let's go back to the Fosbury flop. Fosbury runs with incredible speed and jumps backwards. He has turned his horizontal velocity to vertical velocity. When his back reaches the very top above the bar, his center of mass lies right below his arch back, below the bar. This is the secret behind the Fosbury flop. In the traditional method, high jumpers had to have enough force to throw their center of mass over the bar. But because the Fosbury flop allows the center of mass to be below the bar and further away from the body with the same force, the high jumper can now raise his body to reach greater and greater heights. Thank you for watching.